Plate boundaries. On slide 1, you're going to reflect on the essential questions. If you were quizzed today, which questions would you know the answers to already? Our essential questions are, what is plate tectonics? What are the 3 types of plate boundaries? And what crustal features are formed at the plate boundaries? Your second question is, which question would you need to learn more about in order to answer it confidently? Plate boundaries. Alfred Wegener developed the theory of continents, that the continents drift. At the time, he did not know the mechanism that made this happen. Harry Hess discovered seafloor spreading. He discovered that the magma was rising on the seafloor, causing it to spread. The hot magma rising in the mantle caused the spreading of the seafloor and large pieces of the crust, which is known as tectonic plates, to move. Plate tectonics is the result of both of these theories being put together, continental drift theory and the seafloor spreading theory. It's the theory that the Earth's outer crust, which is the lithosphere, is divided into several plates that glide over plastic-like and less rigid ionosphere, which is the upper mantle. It was developed from 2 previous theories, the continental drift theory and the seafloor spreading theory. Down here, I want you to type in who are the 2 scientists that came up with these theories. For plate boundaries, right here we have the lithosphere, and down here we have the ionosphere. Right here in your own words, you're going to tell me what the lithosphere is and what the ionosphere is. On this slide right here, you're going to find the large plates, tectonic plates, and you're going to put them here. These are the major ones. For instance, you have the Pacific plate. That is a major plate. So you would type Pacific plate right here. On the next slide, you will find all the minor plates or the small plates. For instance, you have the Scotia plate right here. You would take and type it and put it right here. Convection currents. You have they transfer energy in the mantle. It causes hotter magma in the mantle to rise, and it causes cooler magma in the mantle to sink. As you see, based off of the video that you watched previously to starting this, you see where the ridge is and you see the trench. In between, in the lithosphere, you have something that's called slab pull. It pulls the ridge further and further apart until it dies at the trench. Hence the term, born at the ridge, die at the trench. Right here, I want you to tell me if you ever heard of convection before. And if you hadn't, go ahead and just write, I hadn't heard of this term before. Such as, there's convection ovens. Plate boundaries. Continental crust, layer of rock which forms the continents. Also forms shallow seabeds close to shore with a continental shelf. Floats on top of the mantle, which is the ionosphere. The older the ocean is older than oceanic crust and made mostly of granite rock. It's thicker and less dense than the ocean crust. The oceanic crust, the thin layer of crust that underlies the ocean basins. It consists mainly of basalt. It's younger than the continental crust and more dense than the continental crust. Hence the term, once again, born at the ridge, dead at the trench. On this slide, you're going to determine which one of these go to oceanic crust, continental crust, or if it goes with both. So you're going to take and drag and click it over to its appropriate place. For instance, if I could drag and click, less dense would be drag and put into continental crust. Plate boundaries. Look at the diagrams to the left. In your own words, describe what you think is happening in the crustial plate in each diagram. Don't peek at the next slide. So, in A, tell me what you think is happening. B and C, same here. Divergent boundaries is when two oceanic crusts diverge and create a mid-ocean ridge, which are mountains under the ocean. This process is called seafloor spreading. This is where new crust is created. This is also an example of a subduction zone because you have new land being created. The mid-Atlantic ridge actually comes above the ground in Iceland. So you see right here in Iceland where the ridges are being created, you have volcanoes because both of the plates are diverging. Robert Frost wrote a poem in which the two roads diverged in the Yellow Road. According to what we've just read, what does diverge likely mean? You're going to type your answer right here. Divergent boundaries means to divide or to move apart. Two continental crusts diverge and create a rift and valley. New crust is created and is an example of the Great Rift Valley in Africa. Over millions of years, water will eventually fill in the valley and Africa will become two continents. Transform boundaries. That's when plates slip sideways past each other, creating earthquakes. Crust is neither created nor destroyed. Many of these boundaries are found on the sea floor. The most famous transform boundary is the San Andreas Fault in California. Now, as you see right here, this is the picture of the San Andreas Fault. As you can see, nothing is made and nothing is gained, but yet the earth is all scarred up because of it. It's kind of similar to when you get surgery or you get a scar from an accident that stays with you for the rest of your life. Convergent boundaries. What happens when plates converge or collide? There are three different kinds of collisions. You have continental to continental, which form folded mountains such as the Himalayas. You have continental to ocean, which is where volcanoes are formed, and such as the Cascades in Oregon and Washington. Then you have ocean to ocean, which is the volcanic arc of islands that form, such as the Aleutian Islands in Alaska or the Hawaiian chain of islands in the Pacific. Continental to continental boundaries. When two continental crusts collide and push against each other, this pressure causes both plates to rise, creating folded mountains. This is not a subduction zone because the Earth is not making or losing any ground. Continental to oceanic boundary. The ocean crusts go below the continental crust because it makes it more dense. Volcanoes form on the continent. A trench forms at the place when the plates collide. This is an example of a subduction zone because when the ocean crust folds up underneath, as I was saying, the ocean floor folds up underneath the continental shelf and further away from the ocean. The direct result of that is the volcanoes. On the next one, we have ocean to ocean boundaries. When two oceanic crusts collide and push up against each other, the older crust goes below the other one and creates a volcanic arc of islands. This is another example of a subduction zone because it creates new land. Right here, you're going to decide where these go and match them up appropriately. The Ring of Fire, a long chain of volcanoes that surround the Pacific Ocean, one of the most geological active areas on Earth. It's the site of frequent earthquakes and volcanic eruptions. It's caused by plate boundaries converging, diverging, and transforming on a regular basis. On this slide, you're going to tell me in what ways might the ring of fire have changed in shape and size throughout time. So when this was Pangea, where do you think the ring of fire started off at? How big do you think it is? And it was, and how much do you think it's grown? Okay, by looking at a model like a map, how could that tell us if our thought process is correct? That's what you're going to answer right there on that second question. If you have any questions, send me an email or give me a call.